Hello, everyone. Welcome to today's episode of the Cyberman Show. Today, I'll talk about API security basics or API security 101. We'll start with the basics of API. Why do we need API security? The risks around API, some of the security incidents, API security best practices, API security market landscape, and in the last, API versus application security. So get your notebook out. This could be a long episode. There's a lot of content that I've collated from multiple white papers from Gartner, Imperva, Postman, ESG. So I'm thankful to all of them. With that, let's get started. So what is API? API stands for Application Programming Interface. Essentially, it's a way for exchanging data. It's a communication channel. It is designed for software to interact with other software with no user interface or front end. Now, this communication method enables applications to leverage features and data from other applications without need to build everything from scratch. I'll give you an example. If you have a smart TV today and you have done your Netflix login, you'll see the catalog of recent movies on smart TV without logging onto the Netflix app. That's where API is interacting. Then there is API on mobile app. Every time you enable a Face ID on your iPhone for some app during the authentication process, that's also API. So API can be used by any application, whether it is web, non-web, it can be an operating system, it can be database, etc. So in summary, API enables organizations to carry out their business based on the business logic that they have built. Now, today, the use of API is so massive that there is an average of 1.5 billion API calls in a year to enterprise sites, and the API traffic is outgrowing the normal web traffic. So today on internet, 71.3% traffic is API traffic, and it's obvious you can't have logic for everything in your own app, so you need to call other apps, whether you have a search engine like Google that's displaying weather data from your nearby location, or it could be Google Maps functionality getting used in a different application. And hence it is interesting for a threat actor to go after API. Okay. Now, some of the things that you need to know about APIs is one is the communication channel, which is web-based mostly. So web API is the most common one, and there are four common types of web APIs. RESTful, which is most common type of web API, which exchanges data in the JSON format, also known as JavaScript object notation. Then GraphQL API, which is a Facebook supported structure, and it provides database over a single query, single post. And I'll explain get and post later. Then SOAP is a bit of legacy. It uses the verbose XML format and uses RPC, remote procedure calls, and it's still there in legacy APIs. And then gRPC, it uses a more efficient RPC method compared to SOAP, and it is useful for high volume of data exchange and hence mostly used for east-west traffic communication. Okay, so how APIs work is essentially the application. Let's say I want to build my own application that displays the weather data. I can call that API in my application. Typically, I'll write as a developer, I'll write an HTTP request and give a call to the target application. In this case, the weather application. I can write my mobile app, I can write my web application, and I can call the APIs based on the weather application, and the end user of my application will see that data. So it's essentially a collection of HTTP requests and responses. So the request query goes and the response is sent back in the JSON or XML or other format depending on the API that you are using, like gRPC, RESTful, GraphQL, etc. Okay, so that's how it works. Now, essentially, the next thing you need to understand is the common terms that are used in APIs. The number one being endpoints. So endpoint is a specific location within the API that handles requests and send back responses. So imagine there is a building, the API core. Let's take that example of weather service. So the developer of the weather service application has exposed various data sets, example, the temperature, the humidity, wind speed, etc. Or in case of a building, it could be different doors. So every door in the building represents an endpoint, okay, and every door leads to a different resource. So endpoint is represented by a resource path, also known as URI or Uniform Resource Locator, and the operation is performed on it. So this operation could be create, read, update, or delete. And these are typically mapped to HTTP methods like post, get, put, and delete. Okay. So example, if you're doing a get, you are requesting information from a particular department whose room is or whose setup is behind that door that you have queried. Now, it's like visiting the department office to inquire or pick up something that they have prepared for. Example, list of tenants. You are not getting anything new, you're just getting existing information. Okay. The second common query on the endpoint is post, which is giving new information back to the department. And that's why you use this post method. Is like entering the department office and submitting an application like a new tenant application or deliver something new like a package. So you are giving them new data to process. So depending on the application, you are, the API, get and post or update or delete methods could be used. Get and post are the most popular ones. Those who are familiar with web browsing understand that HTTP has get and post very common, and typically when we are browsing, we are essentially doing a lot of HTTP gets, and we are uploading, we are doing HTTP posts. So the terminology is picked up from there. The next term you need to know in the API world is public API. It's an API that is made available and shared freely with all the developers via internet. External API, it's often interchangeably used with public API, essentially an external API that is exposed over the internet. Private API, it's an API that is implemented with the protected data center or cloud environment or for use by trusted developers. Authenticated API, it's an API that is only accessible to developers who have validated their credentials. Unauthenticated API, an API that can be accessed programmatically without the need for specific credentials. Okay, so I'll take a pause. Let me explain this further. Let's say you have that weather service and you only wanted, instead of random developers, you want only people who are paying you for that service to pull that weather information. So I'm creating my own app and I want to have access to the most accurate weather information. And for that, the weather service company that has all this data is investing money, so they want to charge for it. So they will only give me access based on a secret key. So this is, I'm paying them. In exchange, they give me a key through which I can authenticate and get that accurate information. Okay. So for unauthenticated, there are versions. Example, if you want to pull last week's information, which is outdated, you might not need to authenticate. But if you're looking for latest accurate information, you need to authenticate based on the credentials or the key that has been given to the developer from the weather service. Moving on, the next important term is North-South APIs. These are APIs connected to third parties and external systems and apps, typically over internet. Okay, this is what I've been mentioning, the same example of an app connecting to a weather service, smart TV and connecting to streaming apps, and banks and wallets, very common. East-West APIs, these are internal traffic which connects processes to their various processes to their own applications. So in the overall API landscape, what we have spoken so far is the use of North-South APIs that allow you to open your data set to outside world. East-West APIs allow you to share information within your organization, between multiple apps, within multiple business units, and then you are exposing these APIs to multiple other categories. This could be B2B applications who are authenticating. The example I gave you, a paid service which is more accurate to get the weather data It could be generic application, it could be a mobile app, it could be a web site, etc. Okay, so that's the API landscape in summary. Now, as you would have realized by now, there is so much information, and I would like you to notice what's happening around your world and see how APIs are getting used. Developers are not writing everything. Example, anytime I run my app on banking, it requires me to do a Face ID authentication. The bank application is not writing the entire Face ID authentication. It is relying on Apple's API to do the Face ID authentication correctly, and then once the get response from when the banking app gets a positive response from Face ID application within the iOS, it allows me to access the banking application, right? That's how it works. Now, hackers love API because they are like open doors to valuable things. Okay, if you can get into the door, into that department, you might be able to get some confidential data. APIs can show how applications work, what information that they have, and even personal details. So if these doors are not locked properly, attackers can sneak in and cause trouble. They might mess up with how things work, steal important data, or even take control of the stuff. I'm sorry. The scope of API security hence is to secure the APIs that businesses create and expose. So if I'm the weather service business that is sharing this accurate weather data based on the sensors that I've deployed worldwide, I would want only authenticated applications to get that data. Data can be used for research and various other purposes. Okay, so my job is to secure so that cyber criminals should not be able to steal that accurate information and sell it at a cheaper price. This is just one of the use case. Also, there is another scope which most people don't talk about, which is securing the APIs that an organization would consume. So I'm a developer, I'm getting that weather information. And I could be collating information from multiple other sources. That also has to be secured. So inbound, outbound, anything has to be secured in terms of scope of API security. Now let's talk about the security risks. So for that, first understand what is an API vulnerability. API vulnerability is a software bug or a system configuration error that attacker can exploit to access sensitive application functionality or data, or otherwise misuse an API. And this can be done through broken authentication, which is use of weak passwords, improper credential validation, outdated methods. Example, going back to the weather service again, as a developer of the weather service, I allow anyone who has a password called password1 to fetch the accurate data. Any hacker can easily brute force it. Then the problem of unauthenticated endpoints, which is endpoints that are not validated and you expose your API to anybody who sends a request. In fact, Imperva discovered an average of 21 unauthenticated API endpoints per account. Broken authorization, which is giving user access to data beyond what they need or allow unauthorized permissions. Insecure data exposure, which is exposing sensitive data without encryption or access controls. Unrestricted resource consumption, which is excessive requests causing denial of service attack. Security misconfiguration, which is the use of default credentials, unpatched vulnerabilities, unnecessary features enabled. Improper API inventory management, which is lack of awareness of all APIs, leaving some exposed. Unsafe consumption of external APIs, which is improper validation data from external API leading to vulnerabilities. Shadow API, undocumented API, or undiscovered APIs. These are APIs that operates outside the official and monitored channels within an organization. These APIs may be created by well-meaning developers seeking to expedite their work, or they could be a remnant from previous software versions. Then deprecated API endpoints. These are those that have been officially marked as outdated or obsolete by the API provider and are planned for eventual removal. Legacy API abuse, data or content scrapping, logic flaw in API design. This is where making flawed assumptions about user behavior is common. Example, an online shopping app that gives a discount to whole shopping cart when a discount is code is only meant for specific items. And this is the most commonly abused vulnerability. Now, what OWASP has done is they have created a API security top 10 list. It's a useful overview of some of these most widely abused API vulnerabilities that organizations should attempt to identify and remediate. So if you do a search engine on OWASP API top 10, you'll get good results, and most of the things that I've mentioned are there except the logic abuse in the. So this is the list I'm creating in 2024 May. Logic flaws in API design still not covered. I think OWASP is more on the technical side. With that, let's get into the API security incidents that have been possible. So typically how an attack or anatomy of attack would work, essentially you can call them phases of an attack would work, is let's assume there's an e-commerce app running on a container. The step one of this attack would be threat actor reverse engineering the mobile app. The actor discovers a deprecated API endpoint URL used for retrieving data from a backend microservice. In the second step, the attacker notices that neither authentication nor authorization are required for sending API calls to this endpoint. Step 3, the attacker abuses the SQL injection vulnerability. The API endpoint URL provides a unique product identifier in the form of a numeric value, and the attacker runs a series of automated checks to discover that the input field of product ID can be leveraged to carry out a successful attack. So rather than abusing this SQLI for data tampering, the attacker chooses to abuse the SQLI vulnerability and runs a shell command in the microservices running the SQL database. The shell command downloads a malicious executable and executes it. The executable can now run a Bitcoin mining software. Okay, so this is how one of the possible workflows or steps of an API-based attack. Now, what has been happening is there was a survey done by ESG that mentions the type of security incidents that organizations suffered. Various organizations suffered as a result of insecure APIs. This included exposure of data, account takeover, denial of service attack on misconfigured API, fake account creation, API injection attack, ransomware, data breach, content scraping. So all the possibilities of not all, but most of the possibilities of attack that you could imagine are possible. Now, the most common attack vector on API has been business logic abuse, followed by data leak, and then automated attack, spam, protocol manipulation, file uploads, etc. And the most targeted industry has been banking and finance because of obvious reasons. They manage tons of money, and cyber criminals go after them so that they can withdraw money or transfer it in some format. The other vertical has been e-commerce and retail. Again, getting free goods, most common use case, shipping it to different location, etc. And then healthcare, transportation, service provider, food and beverage, entertainment, telecom, etc. So these organizations are the most targeted one. Now, a real incident happened in Australia in 2022, where a telecom company called Optus had to set aside $150 million to pay for replacement documents and identity protection services. In the breach that occurred, what happened is there was an unprotected and publicly exposed API. This API didn't require user authentication before facilitating a connection. A lack of an authentication policy meant anyone that discovered the API on the internet could connect to it without submitting a username and passwords, and that led to a breach of data of more than 10 million Australians. So that's why the company had to suffer so much loss. So API security is very critical for any organizations that is exposing API, which today most organizations are in the hyper-connected world. Now, let's look at some of the API best practices. What I've done is I've also given a checklist on my blog on Substack. It's called the Cyberman Stack. Take a look at it. I'm also mentioning some of it here. So API attack surface discovery is one, which is essentially all about what a potential attacker can see when scanning for API. This process can uncover accidental and uncover unknown API exposure. The next one is API inventory and risk management, which is cataloging API it essentially reveals the number of internal and external APIs across organization. The third one is API threat detection, which is looking into the API traffic, understanding what's happening in this flow, and then API attack response, which is all about detecting API attacks and general abuse. It requires logging, alerting, and blocking. And then, of course, in the build process, pre-production time, you have to look at testing the API to ensure that this is included in the entire DevOps process, essentially a shift-left approach. Let's look at the API security market landscape now. So there is a big market of application in API security. I'll cover the difference between application and API security later, but there are adjacent markets in this space. There are providers who have built anti-bot, DDoS prevention, WAF products, and they are offering API security. Then there are application security testing companies who offer API security testing capabilities or products, and then vulnerability management companies, attack surface management companies who also find exposed APIs, etc., and then anti-fraud companies who are offering the at least publicly exposed APIs in terms of attack surface. Then there are application security vendors who are offering API security. This includes Akamai, Imperva, Checkpoint, F5, etc. Then there is the category of cloud and API gateway vendors. So these vendors offer API gateways, which is essentially a way to manage the API calls. It essentially becomes a single point of entry for all API-based communications. And they are offering API security capabilities, including AWS, Google Cloud, Azure, Tencent, Oracle, Kong, Akamai, Cloudflare, Fastly. And then there is a very interesting subsegment called Cloud WAP, or Cloud Web Application and API Security. Essentially, this segment of products provide comprehensive security services designed to protect web applications and APIs from a wide range of threats. So the most basic capabilities that are there or the core capabilities are WAF, API security and protection, DDoS mitigation and protection, bot management. So essentially they provide hosting capabilities for businesses, and then they offer add-on capabilities that I mentioned earlier, and then they offer other capabilities like threat intelligence, real-time monitoring, API posture management, policy recommended automation, API threat detection and response, access management, fraud detection, etc. And then some of the other capabilities like DNS security, mobile SDK, API gateways, etc., etc. The third category mostly falls under the optional capabilities in the Cloud WAP report. So this is as per the data from Gartner. Now, typically there are two ways that WAP solutions are getting offered in the market. One is the standalone Cloud WAP, which is cloud delivered services without a content delivery network. So this kind of service is provided as a SaaS, offering delivered by the cloud without directing the traffic through a private CDN. And then the second category is the Cloud WAP paired with CDN. So when cloud delivered services are paired with CDN, this is what Cloud WAP category is. And this is provided through a group of geographically distributed points of presence that speed up the delivery of web content by bringing it closer to the where users are located. So they offer CDN and without CDN, and it depends. So Akamai, for example, has acquired No Name Security for API, and they offer these services as a bundle. Again, not recommending any company. I'm just telling how the market is. Then there are dedicated companies who are API security focused. This includes No Name, Traceable, Salt, Sequence, Firetail, and as I mentioned earlier, No Name got acquired by Akamai to increase their API security capabilities. And then lastly, the CNAP vendor. So CNAP has been interesting. The CNAP platforms are providing end-to-end capabilities for cloud native applications, and most recently they started including the API security functionalities. This includes Palo Alto Networks, Checkpoint, Wiz, Orca, Data Theorem, etc. Multiple other vendors. So depending on how your application is, either a CNAP vendor or an API security vendor or a web-based solution could work for you. What you have to look for is essentially your threat modeling, the risks of API that you can be exposed to, and then understanding the right solution that will fit your need. Most important is to understand the API attack surface and then taking a decision. Lastly, let's talk about the difference between application and app security. As you can imagine, and again I'm going to reiterate this, is that API security can be meant for anything. It can be a operating system, it can be a mobile OS, it can be a database. Anything that wants to send data will expose an APIs. Application security hence only looks at the entire application security, while API security concentrates on the API endpoints. Okay, remember that differentiation. So API security is critical for components of comprehensive security strategy. Okay, then they are both essential. And typically in the Appsec approach, what you're doing is you are putting use cases through build time security and runtime security. And build time security is all about securing the software development lifecycle, DevSecOps, SAST and DAST on the most basic side. And then for runtime, typically companies deploy WAF, which focuses on protecting the web-based front end of the application, and then API gateways that help organizations aggregate and manage APIs. So they take care of application security and API security, most commonly using WAF and API gateways so far. But companies who understand the criticality of API have seen the risk. They go with dedicated API security solution, whether as part of a WAP product, standalone API security product, or as part of the CNAP. Now, if I have to summarize, Appsec focuses on entire application, code, UI, data storage, backend processes, etc. The threats are different in Appsec world, including SQL injection, cross-site scripting, unvalidated user input, insecure data object references, malicious code execution, unauthorized access attempts, code reviews, SAS and DAS is how they secure. The API security world, the focus is securing the communication channel, which is the API endpoints, right? So the threats are, as I've mentioned earlier, broken authentication authorization, insecure data exposure, denial of service attacks, improper API inventory management, unauthorized access to APIs, data leaks, etc. And the techniques that we use to protect our API: gateway-based security access controls, data encryption, API rate limiting, API security testing protocols, anti-bot features, etc. Okay, so these are the differences between API and app security. On a high level, app security approach might or might not involve API security, but API security can be around anything that exposes your data. So it depends on how your business is using the API. Both are needed. Both have different purposes. They're complementary to each other. With that, thank you so much to all the listeners who are listening to the content. I do get comments on my LinkedIn. And keep giving feedback. Keep sharing topics that you want me to simplify. Keep reading. Thank you so much. I'll see you next time.